In this video, we're going to consider the factors that firms must manage, the decisions that they have to make about output and cost. The goal of a firm is to maximize its profits, and they do this when they produce the greatest quantity at the lowest cost. And what you'll see in this video is they do this when they produce an output at the lowest long-term average cost. They do this when they balance the benefits they get from economies of scale. And they balance that against the diminishing marginal returns that they will eventually experience when they add factors of production. First, some terminology. Decisions are made in the short run or the long run. The short run is a time frame when some of the resources are fixed, but other resources are not. So your building or factory, you may not be able to change that in the short run. But the amount of labor you have or the amount of raw materials that you buy are things you can change in the short run. In the long run, that's a time frame where all decisions can be changed, even fixed cost decisions, such as a factory or the machines or technology that you're using. Lastly, a sunk cost is a cost that's already been incurred, and as a result, it's not a cost that is considered when making decisions. We talk about returns to scale. There's basically three types of returns to scale. We have economies of scale, where costs fall as we increase our output. We have diseconomies of scale, where costs tend to go up. They rise as we increase our output. And then we have constant returns to scale. And that's a situation where our costs and our output are proportional. They increase together. Now we can look at, when we produce something, at three concepts: our total, our average, and our marginal product. And so as we increase one of our factors of production, as we increase our labor, our output is going to increase. The total amount that we produce is going to increase as we increase our labor. Well, it's also going to have an effect on the marginal product that gets produced and the average product that gets produced. So an example where we go from 2 units of labor to 3 units of labor, the total product that we make goes from 10 to 13, so the total is 13. The incremental or marginal product that we add by adding the additional unit of labor is 3. That's our marginal product. And then the average product that gets produced actually declines. It goes from 5 to 4.33. You can see in the chart here an example of how the total and marginal product increase. So again, when we go from 2 units to 3 units of labor, our output goes from 10 to 13. So our total product is 13, and our incremental product is what's represented by the difference between C and D, which is 3. So our marginal product is 3 units. Now when we look at the marginal and average product and we compare them, we can see that the marginal product, when it's below the average product is increasing. And conversely, when the marginal product is below the average product is decreasing. And there's an optimal point where the marginal product and the average product is at its maximum, and that's the point where the two lines intersect. the law of diminishing marginal returns. This is a feature of economics. When a firm uses more of any variable input, the marginal product of the variable input will increase, but eventually it will decrease. As we keep adding the variable input, the marginal product of incremental units of that variable input will eventually diminish. Marginal returns will eventually diminish. This is diminishing marginal returns. And you can imagine a situation, perhaps it's a sandwich shop where you have one worker doing all the jobs, taking the orders, making the sandwiches, taking the payments, keeping the stock supplied. If you have only one worker and you add a second worker, they can divide their labor and they'll become more productive. If you add a third worker, maybe you can have one of them focused on taking the orders, another on making the sandwiches, and a third on taking the payments. And so the productivity, the marginal productivity will increase. But eventually, if you add a fifth, sixth, or seventh worker, the incremental product will start to decrease. In the sandwich shop, maybe there's only room for so many workers. They'll start bumping into each other and they'll become less productive. So eventually, the marginal product diminishes. We have diminishing marginal returns as we add resources. Now we can look at costs. We're going to look at fixed, variable, and total costs. So the total costs are the total fixed costs are the green line. So regardless of what our output is, that number doesn't really change. So if we have a factory and that's part of our fixed costs and we build 1 unit, the fixed costs are whatever the factory costs. If we build 1,000 units, it's still whatever the factory costs. It's the same number. So our fixed costs, our total fixed costs are the same at each output level. If we look at our total variable costs, they increase as output increases. That's the purple line in our chart. And there's a little bit of a curve to it, but it's upward sloping. And so the more variable, the more output we have, the more our variable costs will increase. And if we can also then look at total costs, and that's simply by adding total fixed costs, total variable costs, and that will give us total costs. And that also has an upward slope. It starts out equal to the total fixed costs, and it goes up and slopes up to the right in a similar shape to our total variable costs. Now we can look at average costs, and we can derive these from each one of our cost measures. If we take the fixed costs, which in our previous example didn't change, but we create an average for it, the average fixed costs will decline. We're going to spread out the costs over more and more units. So in our example before with the factory, if the rent on the factory is $1,000 and we have 1 unit, then the average fixed cost is $1,000. If we have 1,000 units that we're producing, then we spread it out over the entire 1,000 units, and the average fixed costs is only $1 per unit. So the average fixed costs decline. We spread them out over a larger and larger output as we increase our output. The average variable cost is U-shaped. It starts declining, it has a bottom point, and then it starts to increase. Now, we can look at all of these curves together, and we can see that the output where the average variable cost is at the minimum, the marginal cost and the average variable cost are equal. So the marginal cost curve crosses the average variable cost curve at the point where the average variable cost curve is at a minimum. So in the beginning, when marginal cost is below the average variable cost, it's improving the cost structure. And then eventually when the marginal cost is above the average variable cost curve, it's harming the cost structure. And at the point where the two intersect, the average variable cost is at its minimum point. Now we can look at the average total costs. And again, the marginal cost curve is special. At the minimum average total cost, the marginal cost is also equal to the average total cost. So outputs over which the average total cost is falling, the marginal cost is below it. And then once the marginal cost is above the average total cost will rise. And this gives us that U-shaped average total cost curve. So the average total cost curve is U-shaped because there's two opposing forces at work. The first one is that we're spreading our total fixed costs over a larger and larger output, and the average fixed cost curve will slope downward as output increases as we spread those fixed costs over more and more units. But eventually there's diminishing returns because of the law of diminishing returns, and the average variable cost curve will start to slope upward, and average variable costs will increase more quickly than average fixed costs are decreasing. So we're balancing these two types of costs. The total fixed cost that we're spreading over a larger number of units, and the average variable costs, which start to increase at some point because of diminishing returns. Now, the shape of a firm's cost and product curves depend upon two things: the technologies that are available for them to use. Technologies determine how much output they're able to produce, and when you have new technologies that are available, the firm becomes more productive, and the product curves will shift outward, meaning they'll produce more product, and the cost curves will shift downward, meaning their costs go down. And then also there's the prices of factors of production. Anytime you have an increase in the price of a factor of production, it shifts the cost curves. It makes, if it's a increase in the factor of production, then the cost curves will shift up. They'll move up to represent higher costs. So firms have to pay attention to the prices of factors of production and technology. And these are the factors that determine the shape of their cost curves and their product curves. And this is one of the reasons why firms will invest in new technologies as a way of increasing their output and decreasing their costs. And they manage very closely their factors of production as a way of making sure their costs do not increase unnecessarily. Now, when we talk about the long run, remember that all inputs are variable and all costs are variable. So really, in the long run, all decisions can be changed. Even something like a factory, which is a fixed cost that maybe you can't change in the short run, in the long run you can retool it, you can sell it, you can go out of business, you can make it into something else. In the long run is the period of time long enough where you really can change all of these decisions. Now let's talk about long run cost and the production function that firms face. So the production function is simply the relationship between the output attainable and the quantities of resources that are used. In this case, it's labor and capital. It might also be land and entrepreneurship and other types of resources. So in the example we have here, as the plant size increases, the output of any given quantity of labor also increases. Capital and labor work together. Capital makes labor more productive. But as we add more workers, which is a variable resources, there's diminishing returns that occur eventually. So our long-run cost is the average cost of producing an output of a given size, and that depends upon the plant size. The larger the plant, the greater is the output where the average total cost is at a minimum. So if you're going to be producing a small number of units, you want to have a plant with a smaller scale. If you're going to be producing a very large number of units, you want to have a plant with a larger scale. So we can imagine a situation, and in this example we have here, we're going to have 4 different plants. And each one of them, plant 1 has 1 knitting machine, plant 2 has 2 machines, plant 3 has 3 machines, plant 4 has 4 machines. And they're all owned by the same firm. And with each one of those, there's a certain amount of labor to operate the 1 machine, and the next plant to operate the 2 machines, etc. So the firm can optimize its production by making sure it puts its orders that it gets on at the factory that has the lowest average total cost for that size output. Again, so big orders should go to big factories and small firms. Small orders should go to the smaller factories. So we can look here. This is our example when there's 1 knitting machine. You'll see the average total cost curve is U-shaped. It declines pretty steeply in the beginning because it's spreading out units, the fixed costs over a larger number of units, and then eventually it levels off, and then it increases. It increases because of diminishing marginal returns to the variable resources, and there's a low point there where the average total cost curves, the average total costs are the lowest, and in this example it's around 10 or 11 units. And then we have the example of the factory with 2 knitting machines, and here you can see that the curve has a similar shape to it, but the low point is farther out to the right, meaning the scale of production where the average total cost is the lowest is at a greater output. And the same goes with the 3rd factory that has 3 machines and the 4th factory that has 4 machines. And so if we look at all of those curves there, depending upon how many sweaters we're trying to produce in an hour, a different plant might be more efficient than another plant. It may involve a lower average total cost for one plant versus another plant. And remember, the goal of the firm is to maximize profits. It does that by producing the highest output at the lowest average total cost, because profits are equal to revenue minus cost. So in this example, let's assume that we need to make 13 sweaters. Now, 13 sweaters can be most efficiently made on one of these 4 options. And it turns out that the plant that has 2 knitting machines and the appropriate labor for 2 knitting machines can make those 13 sweaters at an average total cost of $6.80, which is lower than it would cost on the factory with 1 knitting machine, where it's $7.69, because there they've already passed the low point on their average total cost curve and they're starting to experience decreasing returns. And it's also true that it's at a lower cost than on the factory with 4 machines, where the average cost is $9.50. And the reason there, you can see, is because at $9.50 on the factory with 4 knitting machines, they're still the average total costs are still very high, because you haven't spread the fixed costs out over enough units in order for it to be efficient. So the least cost way to make 13 sweaters is to do it on factory number 2, the one that has 2 knitting machines, because at on that factory the average total cost is $6.80. Now we can take all four of these curves for the firm, if the firm owns all four of the factories, which they do in this example, and we can make a single curve where, depending upon the volume range, a different plant would be the most appropriate. But you can see this is the planning curve the firm has. It tells them which factory, which number of machines, which combination of fixed and variable costs would be the lowest depending upon the size of the order, depending upon the output that you're trying to achieve. And this would be the firm's long-run average cost curve if you add them all together. And it can function as a planning curve for the firm as they're making decisions about their costs and their output in an effort to maximize their profit. So remember, the thing that we're doing is we're balancing two sets of dynamics. Number one, we're trying to, the firm will experience economies of scale up to some output level. And then beyond that output level, it'll experience constant returns to scale, but then diseconomies of scale. So there's an optimal point where the average total costs are the minimum. And again, we're balancing economies of scale from spreading fixed costs out over a larger number of units with diseconomies of scale that come with diminishing returns as we add more and more of a variable unit. So there is an optimal point. And the minimum point on this U-shaped curve, this long-run average cost curve, is considered the minimum efficient scale. That's the amount the smallest amount the firm can produce and still be efficient. And we see on our long-run curve, our long-run cost curve, our planning curve, that the minimally efficient scale is 15 units. So if they get orders at 15 units, that's the lowest, that's the smallest order they're going to be able to get and produce an output for at the lowest cost. And when they're to the left of the minimally efficient scale, as they increase their output, they're experiencing economies of scale. And when they're to the right of the minimally efficient scale, as they increase output, they're experiencing diseconomies of scale. And so remember, where we started, the goal of the firm is to maximize profits. Profits being defined as the revenue minus the cost. Well, in that situation, we need to produce the greatest output at the lowest cost in order for us to maximize profits. And again, we do this when we produce at the lowest long-term average cost, when we're able to balance the benefits that we get from economies of scale. And we're able to balance those benefits against the eventual diminishing marginal returns to factors of production. And this is the goal, and when the firm is able to do this successfully, then they're able to maximize their profits. They're able to properly manage both their output and their costs. Thank you very much for watching this video.